Good morning, one and all. This is Prashanthi, working as Assistant Professor in Physics Department from MLR Institution of Technology, Hyderabad. So today I am going to explain about wave optics. Under this wave optics, we have many subtopics are available. Those are Huygens principle, diffraction at a single slit, and so on. Now I am going to explain about the Huygens principle. By the end of this session, student will be able to know about the Huygens principle, what is the definition of the Huygens principle. Then he or she may explain about the principle of a Huygens. Nothing but what is the principle behind the wavefront phenomena is nothing but reflection and refraction. Also, they may explain about the diffraction and interference phenomena. And mm, now I am going to explain about the wavefront. Wavefront is nothing but a light will passes in all direction. Initially, the light will passes in all direction. If we join all those locus points which are available on the light rays, which are distributing in all directions, then a spherical wavefront will get. That phenomena is called it as wavefront. Wavefront is nothing but simple definition. A wavefront is a locus of points having the same phase of oscillations is called a wavefront. Then what is meant by wavelet? Wavelet is a point of disturbance due to the propagation of the light is called wavelet. Then coming to the wavefront. Wavefronts are basically three types. What are those? First one, spherical wavefront. Second one, cylindrical wavefront. Third one is a plane wavefront. Spherical wavefront. What is meant by spherical wavefront? To get the spherical wavefront, we require a point source. So then, uh, if we choose a point source, what will happen? The light will propagate in all directions. Then, if we join the locus points which are having same phase of oscillations, then we will get the wavefront. That wavefront is in the shape of spherical. Those wavefronts are called it as spherical wavefronts. Then coming to the second one, cylindrical wavefront. Cylindrical wavefront. To get the cylindrical wavefront, we require a point source which is in the form of linear. If we choose the linear wave source, then you will get the cylindrical shape, right? That is a representation. I gave the representation in second diagram. Those are cylindrical wavefronts. In cylindrical wavefronts purely depends upon the shape of the source, which is in the form of cylindrical. Then coming to the plane wavefront. Plane wavefront is nothing but example for plane wavefront is consider a tube light, right? Then which disturbance in all directions, which propagates in all directions from the tube light. Then complete roll the tube light with black sheet, cut in a corner, cut that black sheet in rectangle shape. Then the light will propagate from the four corners of the rectangle shape. So that if you observe that wavefronts are in the shape of plane, so that is the meaning of the plane wavefront. So wavefront is nothing but wavefront is a locus of points having the same of oscillation, same phase of oscillations, and wavefront divided into three types: spherical, cylindrical, and plane wavefront. Then coming to the Huygens principle. Huygens principle, also called it as Huygens construction. So for this we require a source. Then what will happen? The source will, here I am choosing point source. From that point source, the light will propagate in all directions. If we join the locus points on the light rays, it will give the primary wavefront. And from the primary wavefront, again the wavefront will be wavefronts will generate. Why? How can the wavefronts will generate from the primary wavefront? Is nothing but the locus points which we are joining to get the primary wavefront. Those local points again behaves like a source. So this is explained by the Huygens. So if these locus points behaves like a source, then again the light rays will emitted from the source, then again wavefronts will be generated. Those wavefronts are called it as secondary wavefront. Primary wavefront is nothing but whatever the wavefronts will generated by the main source is called it as primary wavefront. And from the locus points, those locus points again behaves like a source. From that source, again wavefronts will generated. Those wavefronts are called it as secondary wavelets. So this is explained by the Huygens. then all these primary and secondary wavelengths are perpendicular to the source only. That is the main important point. And the secondary wavefronts possess less velocity compared to the primary wavefronts, right? Then these wavelengths, either it may be primary, secondary wavelengths, all wavelengths must and should perpendicular to the source. This is explained by the Huygens. In coming to the what are the behavior of the plane wavefronts in terms of concave, convex and concave mirror, and nothing but what behavior of a plane wavefront in terms of mirrors and lens. Then mirror is all we know about the mirror. Mirror, the light will reflects back. Then from lens, the light will propagate through the lens. When light propagates through the lens, what will happen? Converges through the convex lens and meet at one point. That point is called it as focal point, and the length between the convex lens and the focal point is called it as focal length, which is represented by small f, right? If we use a convex mirror, the image will be very far away, and if we use a convex lens, the image will be very nearer image you will get. That is the importance of the lens. Coming to the interference of waves. What is mean by interference? Interference is nothing but here superposition of two waves. Suppose two waves are propagating, they are combining with each other, superposition with each other, then the resultant amplitude, resultant wave you will get. If you observe the amplitude of that resultant wave, that is more amplitude comparing to the individual waves amplitudes. So we can give an equation that is in terms of amplitude y equals to y1 plus y2, where y is the resultant wavelength of a wave. Resultant wave equals to individual amplitudes of the two waves. Then interference divided into two types: constructive interference and destructive interference. Constructive interference is nothing but in that constructive interference you will get the bright fringes. In destructive interference you will get the dark fringes. Nothing but constructive interference is nothing but the resultant amplitudes of two waves will be summation will be increases, whereas in destructive interference the amplitude will be decreases. Constructive interference the amplitude will be increases, in destructive interference the amplitude will be decreases. For that reason, in constructive interference you will get the bright bands or bright fringes. In destructive interference you will get the dark fringes. That is the meaning of the interference of waves. Interference phenomena is nothing but superposition of two waves is called interference. What is then coming to what is meant by diffraction? Diffraction is nothing but bending of light through an obstacle is called it as diffraction. Interference, superposition of two waves is called interference. Diffraction is nothing but bending of light through an obstacle is called diffraction. That is the meaning of the diffraction. Clear? So this is about the Huygens principle. I think um, wavefront is clear. I think wavefront is clear. Everyone, everyone clear with this one, right? So thanks to IUCE. Thank you.